Good morning, class 10. Today we will see circle. Circle, we have two theorems. This is the most important theorem. First theorem is the radius of a circle is perpendicular to the tangent. Tangent I have already explained, but here I would like to remind once again. A line which intersects the circle at only one point. A line which touches the circle at only one point. So that line is called tangent. And if a line intersects a circle at 2 points, that is called secant. So this is the simple definition. You can understand. This theorem is length of tangents drawn to a circle from an external point are equal. How many tangents can you draw to a circle from an external point? Maximum 2 tangents. How can you draw tangent from a point inside the circle? No tangent can be drawn. Because if you take a point in the circle, and if you draw a line through that point, see that line will intersect the circle at 2 points. So you cannot draw a tangent. So maximum 2 tangents can be drawn from an external point to a circle. So P is the external point for this circle, so center is O, and PA and PB are tangents. So you have to prove PA is equal to PB. PA is equal to PB. Construction, whenever you do the construction in the theorem, you show with the dot dot. This indicates this is the extra construction to prove the theorem. So construction is, so given a circle with center O, P and PB are tangents, and you have to prove PA is equal to PB, length of tangents. If PA is equal to 6 cm, the PB will be also 6. Join OA, OB and OP. Now you see in these two triangles, we will try to prove congruent, and congruency theorem, RHS, AAAs, SAS, ASA, these are the theorems. Now you see what quantities are given in this theorem. OP is equal to OP. It is very clear from the picture, from the figure. OP is common for both the triangles. So OP is equal to OP being common, they are equal. OA is equal to OB, radius of a circle. All the radii of a circle are equal. So OA is equal to, yes, this. And this angle, according to theorem, radius is perpendicular to the tangent. This is the point of contact where the tangent intersects the circle, that is called point of contact. So this angle PAO 90 degree, and similarly angle PBO 90 degree. And therefore, being 90 degrees, they are also equal. So, by this theorem, they are congruent. It looks just like a SAS theorem. Most of the students commit the mistake that they are congruent by SAS. But this is not SAS. SAS, if two sides and included angle are equal. But here two sides, OA and OP, and here OB and OP. So these angles are not equal. So you cannot say SAS. This is proved by RHS theorem, right angle hypotenuse side theorem. What is the RHS theorem? In two right triangles, if hypotenuse and one side of a triangle, right triangle, equal to hypotenuse and one side of other right triangle. So these right triangles will be congruent. and already 90 degree right angle you are explaining, you are mentioning this is right angle, so one angle will be automatically equal. So in two right angle triangle, if hypotenuse and one side, either these two or these two, and this is already, so we are not mentioning the angles, it is already mentioned in the theorem. In two right triangle, hypotenuse on one side of a right triangle equal to the hypotenuse on one side of another right triangle. So these two right triangles are congruent. This is known as RHS theorem. So my dear, these two triangles are proved congruent by RHS theorem. And you know, when the triangles are congruent, corresponding sides are equal. So PA, corresponding side will be PB, the PA is equal to PB. And this was to be proved, the Hebrew triangle. So this is very, very simple theorem. So once again you see the statement, the length of tangents drawn from an external point to a circle are equal. This is a theorem. And the first theorem, as I told you, radius is perpendicular to a tangent in a circle. Therefore, now you will see this theorem. So this is a figure according to the theorem. Circle whose center is O, and P is any point outside the circle. And you know, maximum two tangents can be drawn to a circle. So we have drawn PB and PA. PO is not tangent because it looks just like they are intersecting, but if you extend, so this will intersect the other point, and therefore this cannot be tangent. So PA and PB, इसको extend करेंगे तो this will go outside the circle, so this will be tangent, and similarly also this one. So PA and PB are tangents, so you have to prove these two are equal. You have to prove. So now construction, we have joined A, B and P with the center OA and OB and OP. So this has been divided into two triangles. Both triangles are right angle triangle because this is 90 degree. According to theorem number 1, radius is perpendicular to the tangent at point of contact. Now you see how can you prove. OP is equal to OP. It is very clear from the figure drawn. OP is common for both the triangles, therefore common, and therefore they are equal, they are same. And OA is equal to OB, radius of this circle, all the radii drawn to a circle are equal. And this angle, as I told you, this is by first theorem, the radius is perpendicular to the tangent at point of contact. So these are 90 degree and therefore they are equal. So we are watching here two sides and one angle. But here, once again, I would like to remind you, this is not SS theorem. This is RHS theorem. RHS theorem in two right triangle, the hypotenuse OP for both the triangle, because this is a side opposite to angle A and so of angle B. So this is hypotenuse and one side radius. So therefore they are congruent by RHS theorem. And you know, when the triangles are congruent, corresponding parts of congruent triangles are equal. Short, it is known as CPCT. So by CPCT, PA is equal to PB, and that was to be proved. So my dear, you will use this theorem. Many questions may be asked in the examination, but if you know this theorem and using the Pythagoras theorem, you can find the numerical problems of this based on this theorem. So that's all for today. Thank you and have a nice day.